Alright, hello everybody. I have to remember one thing. After I've spoken for 30-35 minutes, you are one step closer to the party. So that's all you care about right now, right? It's late in the day, so I'm going to try to be as energetic as I possibly can without looking hyped. So there's a fine balance. My name is Christoffer Noring. As Emilia was kind enough to say, I came here all the way from London. Well, it's not that far, but I'm a Google Developer Expert. On a daily basis, I work for a company called McKinsey, where I do a lot of tech stuff, believe it or not. Yeah, we're not known for tech, I know. So, today's topic is GraphQL versus REST. And I'm going to talk to you about the structure. Sorry, you can hear me, right? I'm going to talk to you about the structure of this presentation, so you see where I'm going. I actually have a structure that's held together. I know it's hard to believe once you listen to the talk, but there is a structure, and here it is. So the first piece I will cover is, why should I care? I think this is the most essential question you can ask of a speaker. Why should I care? Because if you don't care, you're just going to listen to a bunch of tech stuff, and probably tomorrow, after a few beers, you're going to remember nothing. All right? The next piece I was going to cover is how to wrap an existing API in GraphQL. So it's a bit practical and it's kind of tech heavy, but I think you can take it. You're all engineers or programmers, right? Last piece I'm going to cover is an attempt to do a REST versus GraphQL comparison. I'm not sure we're going to have a winner, but at least you're going to be able to compare what the different facets of it is. Alright, let's begin. First off, the most important question of all, more important than GraphQL itself, why should I care? There are problems with using REST. There are problems with creating any kind of API that GraphQL is trying to address. The first problem is we have a growing number of endpoints. And what we mean is that we start out with a resource. In this case, we start out with a resource called user. I mean, this poor fellow here, he just has a normal CRUD to him. He has a get user, he has a post user if I want to create a user, he has a put and a delete, and of course, with him comes a lot of other types of gets. That might be reporting queries or some kind of sub-queries on the user. And of course, we start adding products as a resource, and we repeat all of these endpoints again. We add orders, same thing. We add categories, same thing. And suddenly we got 2 gazillion endpoints. And that's all fun, right? And we really love to write all those model classes and all that nice mapping. Yeah, we love it. So it becomes really large, really fast, and yeah. So, there's another issue. It's the fact that resources need to look different depending on what kind of device or what kind of broadband that we're actually on. So, if we are on a normal broadband, we might be asking this kind of query. So here we're asking for a user, and with it we are kind of eager, so we get the region too, we get all of those nice details. This might not be the case, but in a lot of cases this is the kind of questions we ask, and it's fine as long as we are on an internet that's decently fast, right? Eagerly loaded. This might not be the case when it comes to mobile, because in mobile we might actually care about the broadband. It might not be so fast, because it might be 3G or, even worse. At this point, we might actually follow some kind of HTOS model and give a link back, so we can actually go down here and say, well, if we want to know something about the region, you have to make another call. So, and of course, we got a problem here that says, we have different kind of sources. We are coming from Twitter. We want to query Twitter, or Reddit, or GitHub, or some kind of data service somewhere out there. And we want to unify, we want to aggregate all of those data calls into one. So for that reason, GraphQL and its runtime is a very good candidate to try to bind together all of those different data sources. And of course, once we've done that, we just need to have a front end that does a query once. You with me?
Yep.
Yeah, great. That's good coffee, right? The third problem, we don't get the output that we want. And what do we mean? We mean that given that we actually do some kind of get call, we get some data back and it says name and address, but on the other hand, we have a view model in the front end that says, well, I want to call this name here, surname, and I'm going to call the address city. Why? I need to do a lot of mapping here, and I hate mapping. It's boring code. It's not really producing business value. So what I need to do is actually to rename. I need to have a rename layer. Essentially, I'm taking my JSON output and saying, I'm going to put you into a view model, and I'm going to write a bunch of boring property this equals property that. And by the time you're done, you just want to kill yourself, right? So there is also another issue. We might need several endpoints, as I was hinting to. And why is that? Well, if you look at this guy, we have API people/1. That normally means we look for one person. And we get this kind of person. We don't get friends and records at this point. Oh shit, there's sorry about that. So at this point, we have a view model that says, well, first name, surname, and address. That's what I'm getting. And if I want to get friends, I need to do API people1 friends, and then I will get it. So as you can see here, depending on how rich this thing, how deep it is, we might actually need an endpoint call for each. What's the solution? I think you know the answer, right? You know the title. So Graphql. Big surprise. Graphql was open sourced by Facebook in 2015, and as someone was nice enough to tell me, there is a big patent discussion, right? You all read that. GraphQL, can I use it? Now the patent laws are even worse than with React. I think it's gonna be fine, guys, to be honest. I mean, they're just trying to protect themselves from being, sued. Second thing is that GraphQL is really an application layer query language. And that means think of it as a language, but also with a set of tools to help you out. But the most important of all is that we are talking content negotiation. We are able to target one endpoint and tell it, I just want these damn properties. I just want these objects. That's all I want. I'm not going to let you as a backender decide what I want, because I am writing a client and my client is awesome. Content negotiation. And of course, I get to do multiple requests in one call. So I can actually target multiple resources and I just do the one call and it's just going to present me with the nice data that I want. I'm not going to do 4 gets with GraphQL, I'm going to do 1. And of course, there's a type system, so I can actually have type safety. That would be nice, right? So what comes back? You don't have to actually guess what comes back from the backend and see whether it's error, or if it's a nice data, or if it's half empty. You can decide. You can say, these are the types that I expect to get back. And as I was mentioning before, it's easier to aggregate data from many sources. Enough of the sales pitch at this point, so let's talk about how to actually approach this problem, how to solve it. We have some main building blocks. We have schemas. Schemas are a very important part because without schemas we are actually not setting up our backend properly. So those will describe everything that the backend consists of. We have queries. Queries are our questions. No surprise, they're with us. Resolvers. Resolvers are the function that says, given that you answer this question, I'm going to answer you with this data. All right? So a resolver will actually give you the physical data that you want the consumer to see. And mutations. Mutations is just a pretty word for delete, update, and create. So queries is the one hand and mutations is the rest, all right? In a crowd. So how do we query? How do we actually use GraphQL? Well, it's quite simple. You can see this, right? It's late to ask you because, well, I need to increase the font. Here's a query, and what we do in a query is that we say, this is the resource I'm after, and I use curly braces, and I specify what columns I want. Of course, this is very simplified. What if I have a great depth in my query? But I will show that to you as well. But this is the basics. So remember, there's a lot of curly braces involved. Resource, and under resource we specify which columns. And if I have time at the end of this talk, I will actually demo that. Okay. So based on the fact that we do this query, what will my response look like? If I query for a resource, the resource name is what comes back. If I query for certain columns, those are going to match 1 to 1. So here you see, we decide what to call things. Of course, these guys wouldn't exist unless the backend have set them up, but there is a little trick here. We can actually decide what these should be called. Let's look at the query example as we know it. Let's look at some entities that you can relate to. So here's an entity user, an entity order, an order item, and a product. The most fun system ever, right? With these entities, we can see that the user has some kind of list property here called orders. So this one is pointing to many orders. We see that the order is pointing to many order items. And we see that the order item is pointing out a product, and of course the product is not pointing to anyone because, well, it only has an ID and a name. So based on this, I tell you in GraphQL that we can actually dive down all the way to product level, which we do like this. So we say we want users, we want the name of the user, and we dive down into orders, and in orders we say that we want the created column, and under orders we know that we have the order items array, right? And under items we say quantity and price, and under product we say name. So here we have decided that we don't want the full response back, we don't want the full model back with all of its properties, but we choose a sub-selection of columns that we want. And we are able to do a pretty deep call here. And we decide. We are on top of this. It's not the REST backend that decides this is what you get back. We decide. Alright? And of course, the answer we get back is what we can expect. We get the user back, we get an orders array, and under the orders array we get an items array, and under items we have product, and product is more specified what it is. Am I selling it? What are you saying? Looks good, right? Yeah. Okay. Need to up a notch, alright? So here's a query with a parameter. So the query here says, I want users, but I'm able to specify I only want users who fill this query requirement. So this corresponds to, of course, to do something similar on the backend. Just to select from resource where email equals something. So imagine there's a backend system somewhere that you wrap in a service, and you wrap that service into a GraphQL thing. And this is what you're able to do. Just to get you an idea of what it corresponds to. But of course, GraphQL comes with a lot of nice functions that we can use. So we can do contains, we can do is, and not, and greater than, and you know, all the operators that you are used to using in SQL, right? So this comes loaded with a bunch of utility methods that is very good for comparison. So, GraphQL runtime. Now we're talking code. Now we're talking actually wrapping the API. But, before we see some code, we need to remember what we're trying to do here. We're trying to define a schema, we're trying to define queries, mutators, which was create, update, delete, and we need to resolve the query. So when that query comes in, we're able to respond with something appropriate. Alright? And I believe it's time for code. Okay, so this is a hello world example. So the first thing we do here is to define schema object. Under that schema object, we define a query. So we have a query property that we assign to it something of GraphQL object type. At this point, we define a fields object. And under this fields object, this is what we can query on. So the hello property is a property that we can actually mention when we do the query. As you can see here, we also have our resolve method that's not very intelligent because it only responds us with a static string. But this is the bare minimum that we need to make GraphQL work. So we define the hello, as I said, and we define resolve. Really important to remember the resolve, otherwise we have no answers back. And of course, if you look here at the top right, we see that we can do the query, we specify that we want hello, and the response back is hello with the value world. Bare minimum, hello world. Everything else is just more of the same, but a little more complicated. This is the basics. We have a schema, we have an object type, we have a fields, and of course we need to define what to query for. Alright? You with me? Yes. Great. So where do we go from here? Where do we go from hello world to something that we can actually use? More code. Surprise. Okay. So at this point, we have our old resolve with world. We're not so interested in that one anymore, but we add another one that looks more fun. We call this one human. And we give it a type, human type, and the resolve function is now more advanced. It's calling a method called getHuman. And let's start with the type. So the human type is something that has a name human and it has a bunch of fields. Surprise. ID, description, and name, and we give those fields a type here, a GraphQL string, and so on. So, okay, so now we know a bit more about human. It has an ID, a description, and a name. And we know that it has a resolve method. And here should be said about the resolver, because we are most likely to talk to a database at this situation, this is why it wants you to respond with a promise. So that's why I'm using a promise resolve, although I'm using static data. So the promise resolve resolves with an object that represents a human. And those fields, to no one's surprise, corresponds to the fields here in human type. So they just map. All right? So ID is here, description is here, name is here. And of course, our resolver shouldn't be this simple, but it should do some kind of database call against Postgres or MySQL or whatever you have. The important thing is that when the answer comes back, you give it a promise back and it's able to resolve that all the way up until the front end. All right. So once we do our query here at the bottom left, we see that we can specify human, because this is our new property. We can specify name and description. We don't want the ID, remember, we decide. So we decide for name and description, and what we get back is John and a description. You're getting the hang of this, right? Good. Now let's go with a more advanced type, a list type. So here we suddenly have humans instead of one human. So with humans, we have a GraphQL list. We got our human type again, and we know that one had 3 columns. And we got a new resolver, a getHumans. And the getHumans, again, has a promise that returns a list this time. No surprise there. The only thing we need to remember, really, the difference between one human and many humans, is that we need to give it a GraphQL list. That's pretty much it. And of course, once we do the query, we can see that when we ask for humans, a name and description, we get the humans property back, and we get all those fields that we ask for. Of course, this one shouldn't come back. Didn't see that? Right? Now it gets interesting. What about depth? What about the fact that we have an object that has some depth? In this case, we got Luke. He has 2 friends. We got, well, Darth here. He got, one friend, of course. What I'm pointing out here is not 2 as in 2 friends. It's the ID of his friend, right? And we see that Darth has 1 friend, and we see that Palpatine is an asshole, so he has no friends. Pardon my French. We all know that, right? No surprise if you saw Star Wars. Right. Okay, so we got IDs here. How do we resolve those IDs into actual friends? What we need to do is the following. So we go here, we have our human type, and inside of our definition of what the human is, we add the friends property. And friends property is pointing to something of type GraphQL list, and we provided the human into our getFriends. And down here we see that the getFriends is able to process each and every friend here with a map, and this one does a lookup based on ID. So we give it the human. In this case, Luke would be the first human, right? We do lookup on the ID, and what comes back is his friend or friends. Okay, arguments. Of course, we don't want to have these general queries. We want to be able to specify with a specific argument that has a specific value. So what we do here is we give it the argument ID. So this means that we can suddenly use the resource human and say, if you have this ID, try to filter a bit, all right? So we define our argument, and we have a resolver that suddenly is called getHumanById that we provide an ID to, and we see that it operates on a list, and it does some kind of filter operation, and based on that, it will return 1 human or nothing. All right? And of course, we see that what's interesting here is the resolve part, where it actually is able to take an input. And we do kind of destructuring here. So we're able to take the object that comes in based on our query. We're able to dig out the ID and place it in getHumanById. And we do the query. We can see here that our... No, I actually forgot the call there. Excuse me. I will correct that. Otherwise, I'm just going to confuse you guys. That was bright, right? So, come on, thank you. get better, right?
Yeah.
Need to provide the argument, otherwise there's no point to this. So, here we actually give it the ID equals 1, which means it will use the ID and filter it down so we only get loop back and not the whole list. Or even worse, a null. And I see I copy-pasted that bit because it's not returning loop, but a guy called John, so bad database, right? Aliases. Here is what I'm saying. Aliases is your way of deciding what the output's going to look like. So this is really powerful. So an alias is your ability to say that I know in the backend this is called user, but I decide it's going to be called user Chris. So you can do this for each and every column. You can exactly decide what you want, which means all the mapping that you need to do, you don't have to do it anymore. Because you can suddenly make it so that the JSON response that comes back here actually looks like your view model. That's going to save you time. Fragments. Fragments is a way to make your code more dry, right? You don't want to repeat yourself, especially if you've got many queries that almost ask the same question. So imagine that you have a user with 2 properties in a query and a user with 4 properties. And then suddenly you decide that there should be a mandatory field in user and all of those queries need to be updated. So at that point, you'd rather say, wouldn't it be better if I have some kind of construct that's gonna, so I can change in one place? So this is what the fragment would be doing. So this fragment would keep track on what does it mean to return a user detail back. So here I define that the user detail means company, avatar URL, and a list of repos, right? So I replace everything I wrote probably in here with this fragment instead. So this is a way to keep your queries very crisp and dry and for the purpose, and put everything else that's just noise, put that in a fragment. So when you need to add a column or remove a column, this is the only place you change it. Directives. Directives are fun. These are Boolean expressions that allows you to either add fields conditionally or remove them. So that's what they are, like if clauses that says, if you provide me this variable, that means I should not be giving you this skip field. And if you instead do the inverse logic and give me an include, this means I should suddenly be including a list of repositories. So it's really up to you if you want to use skip or include. You just have to remember that they are complete opposites. Make sure your Boolean logic is up to par. Very useful. Mutators, or create, update, and delete. So mutator is a pretty simple thing. The only thing you need to remember when you start off is that it's not a query, it's a mutator. So for that reason, you assign whatever mutation object you create to the mutation property. Make sense? So you define your mutation type, and in this case, we define a delete article. And the delete article, as you can see, it has a ID argument. That would make sense. Otherwise, we'd be just deleting everything in the table, and nobody wants that. Right? So we give it the argument ID, and this also means that our resolver function will be taking an ID, and we have a resolve function here, delete article, that takes the ID. That looks something, well, this is the call of the query. So the difference from doing a query call is that you would use the keyword mutation, and you would say, mutation, whatever name I choose to call it, a suitable number, and, well, here's the thing. We are doing 2 things. We're doing 2 things in one motion. We are doing delete article here, but we're also, because it is a resolve function, this means we can decide what it's going to resolve. So not only are we performing a delete, we are getting probably some kind of status back, if that's how we design our promise. So we are able to say, like, yes, it was deleted, or no, you failed for some reason, right? So resolve goes both ways. Do the mutation, but also do return something. And as you see here, I've been somewhat lazy here. I have a delete article that calls an article service, and probably in there somewhere I'm doing a database call that performs the actual deletion. And of course, a creation is no different than a delete, really. It's only just a new property in this mutation thing. So a create article just needs to ensure that someone is specifying an article when we post this to our GraphQL. And as you can see with the delete, instead it's called create article, but the thing we need to keep track on is when we define our mutation, that we give it an article property like this. So we just specify the article with all the properties it could possibly need to be created in the database, like a title and a description, for example. And like before, we can do two motions in one. We can do the actual mutation call and return some kind of status back that says, yeah, this went good. Right. And the resolver, of course, up here on the right would just say article service create, and it would call a database probably, or some kind of endpoint. So what have we learned so far? We have learned to set up a schema. We have learned to define different types. We have learned about resolvers, how important those are. And directives, we like those. Fragments, to make our lives easier and more dry. Aliases, to rename the column to what we want. And mutators, our create, update, delete. So what about consuming GraphQL? We have talked about how to define a schema, but how would we actually be using this in a client, in a real context? Well, you could be using something like this, right? You could be curling this and just send it to a URL and specify the query property, and as you can see, the query is, our question. And you may have to make sure that the content type is of type GraphQL. This is a bit hardcore, but in a lot of cases, this might be the version that you use. And if you do it like this, you're likely to get, the human's response back that we're used to. But there are clients, of course, that's going to make our life easier, especially if we are liking Vue.js. Anyone? Angular? Yes. All right. I have no bias, I promise. How about React? All right, all right. Well, you know that this is technology from Facebook, right? So, half in there. Okay, so Apollo client. So this one integrates to all major frameworks. This is the sale pitch from them. They say incrementally adoptable, sounds very nice. Universally compatible. Ooh. Not like my computer that doesn't work with anything, but that's another question. Simple to get started with. Well, it kind of is, right? NPM install and you're in business. It's inspectable and understandable. It's built for interactive apps, small and flexible, community driven. And yeah, as I was saying, you just need these two NPM libraries to start with, which is the Apollo client and the GraphQL tag. So you're able to pose your queries. And there's also a very nice Chrome plugin that you should be installing to make your life a lot easier. You will get the slides, I promise. You don't have to type this manually. Some of you were trying, right? Yeah. All right. So there are plenty of playgrounds for you to test this out and see if this is for you. So the playgrounds that exist is, of course, a Star Wars API. The Swappy. It's wrapped in GraphQL. Yeah. And this guy has an opinion, right? How many here saw Star Wars? A few. So you know what he's saying, right? Yep. Give into GraphQL. And of course, here at the GraphQL hub, you can interact with Twitter, GitHub, Reddit, and see what your buddy have for GitHub account, and see whether you have more stars than your friend. Healthy competition. And of course, there are a bunch of links. You got the GraphQL Express NPM library, so you can build a schema yourself and try, see how hard is this. And of course, if you want to cheat and save time, you just use my repo, npm install, and you're in business, right? And the official documentation is on GraphQL Learn. And to sum up, I was supposed to do some kind of versus race here, right? I was supposed to say that GraphQL is good and REST is shit. I think that's what my title said. So, you can actually use both. I mean, this is the diplomatic answer. I know, boo. Right? Okay, so REST has many endpoints, and if you use H2As as a standard, does anyone know how to say that fast? Yeah. Okay, so GraphQL has one endpoint and content negotiation, and REST has a lot of endpoints, and it's boring to write a lot of endpoints, am I right? Unless you can generate that with a tool. REST is an architecture concept. GraphQL is a query language and tools. REST responds with a whole object with a lot of properties, and you specify the columns that you want, right? The properties you want. Thank you so much, guys.